doing good day. We are starting Unit 2 in pre-algebra with PO8. Starting right off the bat with a power objective, comparing and ordering rational numbers, which would include integers and decimals and fractions. Okay. You did take a pretest on this on Tuesday, and the results showed that about 60 to 75% of you, depending on the question, have a pretty solid understanding of this already, which is good. So we'll just reinforce that. And for those that do need to learn it or review it, then we've got that going on today. The symbols that we'll be using, you are very familiar with the equal sign. Right? Whenever you write any equation, that's what you are saying. The two sides of the equation are equal. Okay? But there are other mathematical comparison symbols as well. And they look like these. No doubt you've seen these before. What's this first one? When you see that symbol, what is that saying about the values?
Oh, greater than.
Which one?
The left one.
Actually, that's the less than symbol. Okay? It's the less than symbol. There are many different ways that you probably were taught to remember which is which. What finally clicked for me when I was growing up is that the less than symbol is kind of like a squashed L. Right? If you take an L and kind of squeeze it down, you get a symbol that looks kind of like that. So that's what worked for me. You've got the alligator method. You've got it points to the smaller number, right? There are different ways to go about it, but that is the less than symbol, which means the other one would be the greater than symbol. I once had a student try and convince me that the greater than symbol looks like a squashed G. I didn't see it. I don't know. Maybe I'm missing something. But the less than does definitely look like a squashed L. So that's why I go with that one. What we are going to be focusing on, rational numbers being integers, fractions, and decimals. And there's some clues, there's some hints you can use for all three of them. Okay, this is a key point. So these 5 things can go on a help sheet for you. For starters, convert the values to the same form. Okay, there are some questions on here where some are decimals, some are fractions. It really helps to put them all in the same form. If it's easier to convert them all to fractions, convert them all to fractions. If it's easier to convert them all to decimals, put them all as decimals. But then specifically for integers, compare using a number line. Right? In CO4 of last unit, we plotted points. Go ahead and do that here. If you're comparing, this first one, -7 with -10, make that number line, place 0. Where's -7 and where's -10 going to go? -7 is to the left of 0. And since we're going away from 0, -10 is going to be over here. When you're on a number line, which side is the greater side and which side is the less than side? Fill it in the blank here. The further left on the number line, the blank the value. The lesser or the smaller, right? The further you go to the left, regardless of where you are, even if you're starting negative, the further to the left you are, the lesser the value. The further to the right you are, the greater the value. So if you're comparing -7 and -10, -7 being on the right side of -10, -7 is going to be greater than -10. Okay, so if integers, particularly negative ones, are difficult to compare and think, well, which one's actually greater? A number line is really, really helpful. Okay, you being from Minnesota, you actually have experience with comparing negative numbers in the form of temperature, right, boys? Okay, if you're looking at the weather for the week and you say it's -10 outside today, tomorrow it'll be at -7. Woo! 3 degrees warmer. Yay! Right? Still cold, but there you go. So number lines, thermometers, related to temperature, all that's very, very helpful. For fractions, 2 suggestions for fractions. Number 1, compare values to 0, half, or 1. For example, 7/12 is greater than 4/11. Now, those fractions aren't very common. It's not like 1/4 or 2/5, things that we use rather frequently. 7/12 is greater than 4/11. What I did was I compared these values to 1/2, right? What can you tell me about the value of 7/12 compared to 1/2? Is 7/12 greater than 1/2 or less than 1/2? Okay. If we have a denominator of 12, I'll do it over here. If we have a denominator of 12, what numerator would make that fraction equal to 1/2? How much out of 12 is equal to 1/2? 6, right? So with a denominator of 12, and I chose 12 because that's what I have here, 6 out of 12 is equal to 1/2, which means that 7 out of 12 is greater than or less than 1/2. Greater than, right? If you've got a bar and you divide that bar into 12 sections, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6 of those sections filled in is equal to 1/2, right? If we've got 7 of the 12, well, now we're greater than 1/2. And that's all I really care about. All I really want to know is that 7/12 is greater than 1/2. Because then when I look at 4/11, with a denominator of 11, what numerator is equal to 1/2? This one's a little bit trickier because the denominator is odd. But with a denominator of 11, what numerators would make that fraction equal to 1/2? 5.5. We don't have 5.5. We have 4. So is 4/11 greater than or less than 1/2? Less than. Because 5.5/11 is equal to 1/2. We only have 4. That means that this fraction is less than 1/2. So if I've got a fraction, 7/12, that's greater than 1/2, and I'm comparing it to a fraction that's less than 1/2, doesn't it stand to reason that 7/12 is going to be greater than 4/11? The fraction that's greater than 1/2 is going to be a greater value than the fraction that's less than 1/2. Okay? It sounds like fractions are going to be something that we're going to want to focus on. Just kind of gauging the temperature of the room right now. Okay? So we'll come back to this when we get to some practice work. But that's one method that you can use. Compare to 0, half, or 1. That can help you compare both fractions together. You can also use equivalent fractions. We did that in CO6 in Unit 1. Getting common denominators with 12 and 11. That common denominator is pretty big. It's 132, right? So in that case, it was probably easier to just compare to 1/2 like we did. For decimals, the stacking method. Who's used the stacking method before with decimals? To where if you're comparing, I don't have one here, but if you've got 0.8 and 0.53, the classic mistake with decimals is that folks look at the 53 and they say, ooh, 53 is bigger than 8. So 0.53 is greater than 0.8. What's the problem with that logic? What's the problem with that logic? Aiden?
That if you put an extra 0 after the 8, it's 80.
Right. It's not like it's 53. It's 53 hundredths, right? That place value matters. And that 8 there isn't just 8, it's 8 tenths, which when you write it in hundredths means you have 80 hundredths. And now that those decimals are out to the same place value, now you can look at it and say, oh, 80 is greater than 53 because they're out to the same place value. Okay. Oftentimes students just look at the numbers that they see. 53 is greater than 8. Yeah, but it's 53 hundredths compared with 80 hundredths. Okay? So those 5 things, helpful tools, helpful tricks that can assist you in comparing and ordering rational numbers. So let's look at some integers here. Okay? Do I have, yeah, decimals then, yeah, okay. Integers. We already did -7 and -10. We said that -7 is greater than -10, so we'll put the greater than sign in there. -4 and +2. Raise your hand. -4, +2. John? -4 is what to +2? Less than. So you would put the less than symbol there, right? If you looked at a number line, there's 0, while +2 is on the positive side, -4 is on the negative side. Obviously, anything on the positive side will be greater than something on the negative side. So -4 being less than 2, we'll put the less than symbol there. -2 and -9. Raise your hand for that one if you'd like to share. -2 is, Carly? Greater than -9. That is correct. If we look at the number line, here's 0. We're dealing on the negative side, so we got our 2 values there. -2 is on the right side of -9. Therefore, it's going to be greater than -9. Lastly here, -14 blank -12. -14 is blank to -12. Here's our number line. 0's there. -12 is going to be somewhere about there. -14. -14 is blank to -12. Gigi. -14 is less than -12. Yeah. Okay. And the reason why is because -14 is on the left side of -12 on the number line. Okay. So those other 4 you to practice with, homework for you to do there, and then order the integers from least to greatest. That means that the smallest number comes first. So let's just pick. We'll do the first one there. 7, -3, -6, 5, 0, and -8. What's our smallest value there? If we're ordering these from least to greatest, we want the smallest value listed first. What's that going to be of those 6 values? Just someone new. Sasha. -8 is going to be listed first. That is the smallest value. What comes next? Think of your number line. What comes next? Hanukkah? -6. Then, Connor? -3, good. Then 0. So all the negative numbers would come first, which makes sense, right? And then Aiden? 5. And lastly comes 7. If we were to plot those numbers on a number line, this is the order that they would appear in, right? -8 is furthest left, then -6, -3, 0, 5, and 7. Okay, so the rest of the integer section for homework tomorrow. Any questions on this? All right then. Next page, on to, I think decimals come next. Yes. So here we get to practice that stacking method. Okay, we're still comparing using less than, greater than, or equal to. In this first example here, both decimals go out to the thousandths place. If we were to stack them, they'd be out to the same number of places. So here we can just look and say 223 compared with 793 because we're talking about thousandths for each of them. What symbol goes in between those decimals? Connor? Less than. 0.223 is less than 0.793. Okay. Next one, 67.4 compared to 63.22. What symbol goes in there? Carly? Greater than. 67 holes is greater than 63 holes. Doesn't matter what comes after that. 2.54 compared with 2.5400. What symbol goes in between those to compare them? 2.54, 2.5400. You found? Why are they equal? Right. You can add zeros on to the end of a decimal forever and not change the value. Because what are you saying here? You're saying that this decimal has 2 wholes, 5 tenths, 4 hundredths, 0 thousandths, 0 ten thousandths. Well, thanks for that, but that's a little TMI, right? You don't have to tell me there are no thousandths and no 10 thousandths. I can see that, right? Same thing for just writing 2.54. There are no thousands, so we stop. So they're equivalent values, equal sign. Let's do one on the bottom row. Let's do 3.01 compared with 3.001. 3.01 compared with 3.001. What symbol is going to go in between those decimals? Connor? Greater than. Good. Okay. Let's apply the stacking method here to see this. 3.01, that goes out to the hundredths place. And then we have 3.001, which goes out to the thousandths place. So if I fill in zeros in my top decimal, because you can do that, right? You can add zeros on. I've got 10 thousandths compared with 1 thousandth, right? And 10 thousandths is greater than 1 thousandth, therefore 3.01 is greater than 3.001. Let's do the first decimal question here, ordering from least to greatest. We've got 4 of them, so let's stack them up. We've got 0.884. We've got 0.89, 0.879, and 0.088. Notice I was very careful to keep my place values lined up in even columns there. Okay. Since my furthest out decimal goes out to 4 decimal places, that last one, that means I want to fill in zeros on the rest of them so that they all go out to 4 decimal places. So I can accurately compare them. And raise your hand if you can tell me which decimal is the least. Which one would be written first here? Maggie? 0.884 being the least? 0.0884 would be the least. 0.0884. And I can see that because, I'm looking, now that they're all to 4 decimal places, I can compare 8,840, 8,900, 8,790 with 884. This one doesn't have any tenths compared with the other ones that have 8 tenths, so that will be the smallest. What comes next? Anna. Good. 0.879. Right? Comparing hundredths now. 7 to 8 to 9. I've already crossed that one off. I've already used that one. So 700, 800, 900. This one's going to be next. Which one is the next least? That makes sense. What goes next on my list here? 0.8840 or 0.8900? 8,840 ten thousandths or 8,900 ten thousandths? Aiden?
8,900? No, 8,840.
Yes. Right? And then 8,900 or 0.89 is going to be my greatest decimal. Okay? That stacking method is a nice way. If your brain has been trained, just look at the number after the decimal and compare. The stacking method allows you to do that as long as they're all out of the same number of decimal places. Okay? So the rest of the decimals for homework for tomorrow as well. And then on to fractions, which in our little intro seemed like there were a few more than a few confused faces. So let's take some time to go over this. 3/6 and 5/10. What symbol is going to go in between those two fractions? 3/6 and 5/10. Annika. Equal. How do you know that they're equal? Not directly or not cleanly anyway, but 5/10 does simplify to be 1/2. 3/6 also simplifies to be 1/2. So in this case, we used our knowledge of simplifying fractions to say, well, if they both simplify to be the same thing, then they must be equal. Okay? How else could you figure out that these are equivalent values, that these are equal? What else could you do? What other methods do we have involving fractions? Clue number 4 on the front page was use equivalent fractions, which we kind of did here by simplifying. But what's the least common multiple of 6 and 10? To where if we were to write these fractions with common denominators, what's the least common multiple of 6 and 10? Yeah, 30. So if we rewrite these fractions with a denominator of 30, 6 times 5 is 30, so 3 times 5 gives us 15 thirtieths. For 5/10, 10 times 3 is 30, 5 times 3 is 15 thirtieths. Oh, look at that. We get the exact same fraction when we go with common denominators. Okay, so a couple different ways to tell that those are equal. The next one, 3/8 and 7/12. You see that 7/12 again there. What do you want to do for this? What's going to be your method to compare the values of these fractions? 3/8 and 7/12. Aiden?
Find the least common multiple of 8 and 12.
You could do that. Okay? So what's the least common multiple of 8 and 12? What are we going to be writing these fractions? 24. If we rewrite 3/8 equal to something out of 24, 8 times 3 is 24. 3 times 3 is 9. For 7/12, 12 times 2 is 24. 7 times 2 is 14. So now we're comparing 9 24ths with 14 24ths. What symbol is going to go in between those two fractions? 3/8 is what compared to 7/12? Or 9 24ths is what compared to 14 24ths? Two hands in the air. 9 24ths is what compared to 14 24ths? 3 hands, 4 hands, 5 hands, 6 hands for the same people. Connor? 9 24ths is less than 14 24ths. Yep. 9 24ths is less than 14 24ths. You think about those being a test score, right? Both these tests you're probably going to hide from your parents, right? But 9 24ths is worse than 14 24ths. What's another way that we could have come up with a less than symbol? And this is what I was trying to explain earlier and got a lot of blank stares back. So another way, rather than common denominators, is to think about these values compared to 0, 1/2, or 1/2. Both of these values are pretty close to 1/2, right? 3 out of 8 is close to 1/2. 7 out of 12 is close to 1/2. If we have a denominator of 8, what numerator would make it equal to 1/2? What out of 8 is equal to 1/2, Aiden? 4. We only have 3. So what does that tell us about 3/8 in comparison to 1/2? Is it less than, equal to, or greater than 1/2? Hold on, let me.
You have to pull up this very second.
It did, didn't it? All right, we're back on it. So 4/8 would be equal to 1/2. 3/8 is less than that, right? So we can say that 3/8 is less than 1/2 because if it were 1/2, it'd be 4/8. 7/12, like we talked about on the front side, right? If we've got a denominator of 12, what would be equal to 1/2? 6, right? Do we have 6? No, we've got 7, which means that 7/12 is greater than 1/2. So we've got a fraction that's less than 1/2 compared with a fraction that's greater than 1/2. Obviously, the 3/8 is going to be less than. Okay, so this is it really is a great way to look at fractions and figure them out mentally. Okay, if you're just comparing to those target numbers, let's look at another one that maybe would be a good one to. Let's do 4/5 and 7/9. Okay, 4/5 and 7/9. Actually, no, that's not a good one. I take that back. Let's do 5/11 and 14/33. We'll just do the next one there. Okay. For 5/11 and 14/33, what common denominator could you go to? 33. That would work. Okay. 5/11, if it was out of 33, what would that be?
15/33.
Okay. How does that compare with 14/33? Greater than, equal to, or less than that, Carly? Greater than. 5/11 greater than 14/33. Pick another one of those 5 remaining that you want to do together now in class. Annika. Oh, good, yeah. So 13/4, an improper fraction compared with 2 3/4. One of the clues, one of the hints on the front page was putting them in the same value, right? So do we want to convert this to an improper fraction or convert that to a mixed number? Annika, what do you want to do? You want to convert to mixed numbers or convert to improper fractions? Okay, so we already have this in mixed number form. We want to convert 13/4 to be a mixed number as well. Who can explain the process for that? How many times does 4 go into 13 evenly? 4, 8, 12, right? It goes in there 3 whole times with 1 left over. So when we compare them in mixed numbers, it's very clear we've got a value that is greater than 3 wholes compared with a value that's less than 3 wholes. What symbol is going to go in between the fractions? 13/4 is greater than 2 3/4. Exactly. Okay. These done at the bottom here, you've got more than just 2 values to compare. The first one, you got 4 fractions. The second one, you got 5 decimals. And the last one there, you've got a mixture of decimals and fractions. So that one especially, you might want to look at converting them all to the same form, okay, when you make your comparisons. So 2 sides of homework tonight. It's not due until Monday because tomorrow being the retake day, we won't go over the homework. So you have a couple extra days to do it, but please don't forget about Con tonight. And if you have any retakes that you would like to take tomorrow from Unit 1, give me your practice work before the end of the day so I can correct it and have everything ready for you to go. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Okay, that is how you math.